Particular section of this video, what we are basically going to look at is that of the k-nearest neighbor. So how does this k-nearest neighbor? Know that this k-nearest neighbor falls under that of the sub-module of that of the our Sklearn. So this k-nearest neighbor, unlike that of decision tree that we actually encountered before, this k-nearest neighbor works by making use of that of the distance between each of the feature, and one of the distance he actually make use of that of the Euclidean distance. So this on my word part, let's actually, for the calculation of the distance that k nearest neighbor, the other complex thing that k nearest neighbor actually uses, but let's look at that of the distance. That, or it makes that of the, you know, this is more like that of the Euclidean distance, square root of that of the s2, I have that of the s1. So, and also we have the, everything all squared, simple as that. I'll have that of the what, our y2, minus our what, our y1. So everything squared. Remember that everything have to be square. So this is one of the Euclidean distance that this k nearest neighbor actually make use of. So each features you are sending it into it is calculating the relationship by that of make use of that of the distance. So we're not going to go into the more of the complex part of this of the k nearest neighbor, but we're going to look at when it comes to that of the classification of the k nearest neighbor. They make use of the formula. Let's assume that this is the output. Let's say the output is y. So what it actually does is make use of the mode. When I mean the mode, the highest of the neighbors, this is n. Let's assume that this is the n for that of the neighbor. So this is for the classification. It makes use of the most or the highest of the neighbor. So when it comes to that of the classification, it makes use of that of the average. And the formula that it makes use of, let's assume that this is for, remember that this is for regression, sorry, this is for classification, this other guy, and this second. So the formula that it makes use of is that of the you have that of the summation of that of the y1. So this is, we can say yi, not y1. This yi signifies that of the neighbors, and they will have one divided by the k, forgotten the formula, and then here we have the k, here, and then we are having the I initially to be that of the 0. So this is for what? This is for regression problem. This is for regression. Let's actually give you a reg, and this is for what? Classification program. So these are actually some of the things that you should actually know. So if you are interested in learning more of the formulas, you can head online there. You make use of a whole lot of formula to actually find this stuff, all this distance, and then try to calculate it and make a predictive output. But these three guys are one of the important ones that you should actually know. This of the Euclidean distance, we'll have this of the for the classifier or for the classification, and this is what the formula uses for the output of the regression program. So this is what basically we are going to actually learn how to actually implement this in that of the Sklearn. So let me bring this down. Let's actually go up. Let's actually import. Remember that I said they belong to that of the k neighbors. So simple as that. So we can say from they belong to the neighbors in that of the our Sklearn. So you can say from our Sklearn, which is Sklearn dot what neighbors. That should be neighbors. Yeah, want to actually import our what? Want to import our what? K. This is actually k nearest k neighbor classifier, and I will have that of the k neighbor regressor. So there's not really more. The use case of this of the k nearest neighbor and the classifier are basically almost the same too, with how we make use of other ones, like when we did for just like how to save model and load model. If you remember that if you're using classifier, use it on a classification based data. If you're using regression, use it on regression based model. So regression based data, not actually data that I want us to actually make use. This is what we're able to look in our previous video. I think a video before our previous video. So I can come down here. I have two data I want to actually use for the classification and for that of the regression program. So this is data that I want us to use for this classification data. We have actually encountered this data earlier, so it's not actually new to us. And for this regression, maybe we won't have actually encountered this. So let me actually get rid of this. So I don't need us to actually start the pre-processing. So let me actually get rid of this. So let's actually make use of some data that's actually being pre-processed already, but data is actually similar. So for this of the regression, this is our target, and for this of the classification, this is our target. So for this classification, what we're basically going to do is just to actually just to encode this of our target directly. So that's just basically what we are going to do for this of the classification. So let's actually get rid of this. Let's actually take it up. Let's actually drag it up somewhere, because we have done similar stuff here. I think for the classification we did similar stuff here. I think this was exactly the same data. Then the age. Okay, let's actually make use of this. So this is actually, we did similar stuff like this. This was the classification data. I think that's exactly the same thing that's actually down here. So there's no need for this. So and this on this of our classification data, we have the age column, we have the salary, we have the year experience. And for this of our target, when we came here, we encoded it by making use of that of the label encoder. And this our S is our input feature, like I've explaining up to this point. The S is our, like you can see, the age, the salary, the years experience. So they are just basically the same way you can actually implement them. So instead of decision tree, we are going to say our what KNeighborsRegressor classifier, simple as that, and then you can actually implement it. It is okay. Let's actually look at look at some of the accuracy score, the confusion matrix. Remember all these things I've explained all these guys over and over, so I don't see the need to start afresh to actually explain them again. So let me just, I don't want to delete this script. Let me just take it up. Okay, let me just add these ones too with it. I don't want us to actually mess up this script, because we should be using this script as a starting point, so we don't need to actually waste much time on one particular project. So let me just actually take this. Let me take it up, maybe somewhere that we don't need to encounter it again. Okay, so this actually settles it. So we have this of our classification. This is data that we want to actually make use of. This is small data, and then we turned it to a pandas data frame by converting it to pandas data frame. The data converted to pandas data frame because pandas work well with this of the Sklearn. So we pick the features that we want to actually forward to actually get it, to map it to this of the target, and the model that we actually picked was this of the KNeighborsNeighbor. So these are data. Is a good idea. You want to know how well your model is actually performing. You need to actually set that of the train test split. So you can actually set it, but I think I've done that so many times. So let me just copy this. Then I'm going to explain to you how it works. So this is actually it. And here we are going to make use of our S-train. Here we're going to make use of S-train, and then we're going to make use of our S-test. So let me explain what is actually going on here. So like I started earlier, I said that for this, so this is data that we're basically using, this data here. If we actually run it, we're going to get a data frame. So let's actually run it. So in case if you are still new, so we are going to say our df. So let me just shut down every other stuff. So let me just comment all these guys out. So in case this is not actually a tutorial on how to make use of Python and how to actually understand Python. All these guys, I have actually explained all these guys. So I just run it. So I want us to have a feeling of how this actually was. Not this how we have actually been making use of this of df, or I can say this variable df for a very long time. So what we basically, this is data we just turn it to a binary data frame which can be easily be read by anybody, which you can see this is the age colon, the salary, and that the year experience, and this is our target. So there's nothing really much that we did here, and then we forward it, we give our our features and our target. These are features, things we want to actually find the relationship on how it was actually able to get this target. This is more like, say, let me get this. So this is more like saying, why if age is 21 and the salary is 28 and the years experience is 1, why did he get this? Yes, because this is more like that. It doesn't have any relationship as well. This is just a data that I just picked up. So as of now, we encoded this yes to be a label encoder. I've explained what label encoder. This is just more like saying yes is now going to be 1 and no is going to be 0. So if this age is 24, salary 33,000 and the year experience is 1, why did we get no? So this is what features is basically all about. So these features, we are going to use it to map into this of the target. So that's just basically like the ideology behind that of the supervised learning. So this train test split, I have a separate video I explain this is what this train test split actually is. This train test split guide that we have here is more like this for training. Let's look at this train test split exactly here. This is going to split our data based on the amount of test size we actually set it. I know our data is this of the x and of our y. So this is x and of our y is data that we are going to split. When we split, let's say, remember that when we got down here, our data was total of I think that should be 15 rows, because I from 0 to that of the 40. That 15 rows. So it's going to split it. It's going to take 20% of it for testing and 80% for training. This is actually the best. So that's why we extract this, and then we initialize our model, which is KNeighborsClassifier. There's actually KNearest and neighbor, the name actually, and then we fitted it on this. So this will be y underscore y train, not actually y test, because the y train is for, it has more data. This s train and y train has more data compared to this of the y test and this of the s test. This s test and y test are for testing. The model have never seen this data. Hope that is not actually confusing. So these are for testing. So the test size, we set it to 0.2%. This random state that we actually set here just to make sure that all the time we run this, we are still going to get the same test, you can say test data and that of the training data. So it won't become randomly, because on default is actually random number. So you can see that this test size is 0.2. That we want our test size. By setting that of the test size, we can actually control both the test and that of the train. If we set this to maybe something like 33, which is actually 30%. So 30% of our data is going to be used for testing, but it's always wise if your testing is actually 20% or maybe 15%, but nothing below that. So your model can have enough data to actually train properly. So this when we come to this nearest neighbor, we need to actually set the neighbors that is going to look into. So we have that of the n neighbors. Normally default just set it to 3 is okay. Even our data is actually small. So we're going to make use of that of the nearest. Sorry, why do I keep doing this? We're going to make use of this nearest neighbor to actually predict our S test. Remember that the model have never seen that of the S test. So let's actually do that. Remember that this nearest neighbor tends to have other parameters, not just these n neighbors. Remember that. So let's actually run this. So we are going to check the accuracy. We want to know how well the model actually performed. So this is just basically, remember for accuracy, I've talked about this accuracy really well. So accuracy is just more like saying the true and the predicted. Confusion matrix, the true and the predicted. The classification, the true and the predicted. The true is one that actually was being passed. When I mean the true, that's the actually value. When I mean the example, I saying that's 44, 62, 10 is yes. The true is this of the yes. But when the model predict, the model can actually might predict it to no. That's actually what is actually being predicted. So as we can see here, let's actually go up a little bit so we can see some errors that appeared here. So this is actually because our data is actually basically small. So we have this of the y predict. This is actually what was actually being predicted. If I'm looking at the amount of data that was actually being predicted, we have only 3 data that was actually being sent for that of the testing, and we have the accuracy score of 66.6, and this is the confusion matrix. When we look at the confusion matrix, we know that these zeros signify I think that should be true negative that was actually predicted true and that was true. I'll have this of the true positive. So out of these 3 that we have here, was able to predict 2 to be positive, which is to be 1, and then the 2 were actually out of the 3, 2 were actually correct. So that actually makes sense, because if we mass the accuracy, we make use of that of the mass, what is actually predicted over total number of prediction, it should give you 66.6. so this is actually false positive. Predicted 1 to be positive, but it's actually false. It's actually that of the negative. You can see that our model was performing 66.6 accurate as of now, even though the data is not actually enough. So we have this of the precision. The precision, you can see the precision initially was 0, then it turned to 0.67, and then we have the recall 0.0, and then we have the 1.0, the F1 score 0, and then 0.8. These are the supports. So that's just basically it on how to make use of K-nearest neighbor. The Sklearn tend to make it easier to make use of this K-nearest neighbor and some other some other modules or other models that actually exist. Because if I were to write this as K-nearest neighbor from scratch, this is actually going to take a whole lot of time to actually complete. But with help of Sklearn, things is easier for us. You can just directly apply it directly. So in case if you want to actually make use of that of the regression, is basically simple. Since in our previous video we're able to do something relating to that of the regression, which is predicting house price, so we can just use similar ideas. So let me just comment this out. So we're going to actually, because these are the 3 ways we can actually use to actually we can say evaluate how well our model is actually performing. And one thing you should remember is that if you want to predict your custom data, you can actually set it here. So we want to predict, let's say you want to actually predict something like, assuming that we have the age maybe to be 100, the salary to be 50, maybe the year experience to be 50. So here you are going to set it. You can say the age to be, assuming age to be 100, you can say 50, and then 50. The model is now going, when you run this predict, so you cannot actually make use of it because this is actually for testing. So you are going to see what the model actually predicts for you. So let's actually make our custom prediction. Let's actually run this. Remember, I just commented the other one, so we won't have any issue. So we want to actually know what from the model, what did they actually predict. The age is 100, and then your salary is 50, and your year experience is actually 50. Let's actually what is actually going to predict for us. Remember that this data we're using to train the model is really small. So the video is actually like 2 years actually. So we can see the model predicted once, and see how simple this was actually to do in case you want to predict your own custom data. So for our regression purpose, we want to actually do for that of the regression. So let's actually comment all these guys out. So let me just come down here. I don't want to draw a graph right now. I'm just actually get rid of this graph. So this is data we actually used earlier. So let me actually resize this a little bit. So we're going to change what our DF is now going to be. So let's actually have data copied. So I think this should be, let me go down to, I have the regression data that I have here. So this is just basically regression data. So our DF, we are now going to make use of that of want to turn it to a data frame. I like working with data frame. This name must actually turn into a data frame, but I think data frame will actually give us more insight. So we'll have this of the regression. This is regression data. So I think that basically if we are to print the data frame, it's basically going to print exactly the same thing that we saw before. So we have converted it to that of data frame to actually easier for us to work with, and then we basically did the same thing to actually split it. And something we saw here, this of the .ilog, we've actually looked at this .ilog. I explained really well in my video on that of the pandas, but this ilog basically makes use of the formula RC, meaning that the row and the column. Sorry, what have I done? The row means all the rows that exist within our data, and the column means which column do I want to actually. So it's going to, since normally I can set 0 here, but the end of me is setting 0, so I just left it like that. So it's going to be age to this year experience, going to neglect the last column. So the last column, I can see for that of the y, we set to that of the last column. This signifies all the entire rows. You can see how this is basically simple. Remember that this train test split that we have, you can actually do this by automatically by yourself by making use of this ilog of a guy. You can actually limit the number of rows that you actually want, but rather than doing all this complexity and stressing yourself all the time, why you just make use of this train test split? Just make everything really easy to actually make. Like I've explained, the same bit ideology still apply here. The train test split, and then instead of linear regression, which we actually used earlier, so we can actually use that of the KNeighborsRegressor. They are both. Remember that this data were actually trying to solve. Our target is more like that of the regression problem, and our classification, and one we did for the classification was actually that of the 0 and 1. It was being encoded. This data we have actually been using for a very long time up till now. So if you the last video, you should be able to if you see us when we actually printed data, but this is our target. This is actually a regression data problem. This is our target, this is our age and the salary. So that actually explains a little bit more. So, and then we are going to predict that of the S-test. You can actually do custom prediction here to get your output, and then this of our MC. Remember, if you want to do custom prediction, just have to come here, set the same thing, maybe 23, 45, and then 67. Remember that the 23 representing that of the age colon, because that's what we used to actually train the model. Another one, salary and year experience. 45 is the salary, and year experience is that of 67. You can actually run in to see your prediction. So, but I'm interested in just predicting that of S-test, the model. I've never seen that of the S-test data before. So let's actually run this and see. And after we are done running this, we are going to do our own custom prediction. So to see how you can able to predict your own data by yourself. So when we look at this, you can see that we have the MSE to be 4. This is actually 1, 2, 3. We have 1. This is actually 44 million. I have the MAE to be 4,533.3. This variance is actually, or the R2 score is actually that of 0.84. So this is actually brought to actually go. So if you change the model, you are going to get different results. If you increase the data, you are going to get different results. If you process your data, you are going to get different results. So the result is not actually on the same thing. If you do fine-tune the model by changing some parameters, you are going to get this different results. So that's just basically it. So remember here we didn't say that of the neighbors or other things. No, actually you must actually set that the default value can also perform well. So these are basically, you can make use of that of the KNeighbors in the simplest way possible without needing to actually looking at JabBrush stuff. Like how we can see here, this is the distance, this is the y, and this is when you look at this is for that of the classification base, and this is for regression based formula that it used to for the output. Remember, it is for the output. Why for the it makes use of that of the Euclidean distance for the mapping of the distance or the neighbors. So that's just basically how these KNeighbors actually work. So I think this actually concludes. If you have any other question concerning this nearest neighbor, you can actually leave it in the comment section down below, or you can actually go to that of the Sklearn site. They have a well detailed on how this KNeighborsRegressor actually, or the classifier actually work well. You can also look at some formulas out there that you can actually use in case if you are motivated, maybe you want to start afraid to write all these things down. So you can check it on their site. The link to their site will also be in the description down below, so you can actually check it out. So this concludes it for this of the KNeighborsRegressor I can say K-nearest model IDs for the classification and for that of the regressor. So thank you for watching this.